Thank you very much for joining part 2 of the groundwater flow and chemical properties component. To begin with, I want to mention that this section will focus more on groundwater surface water interactions. My name is Kawawa Bande. Right, so diagnosing relationships between surface water and the underlying aquifer is an important component of aquifer characterization. It is important to distinguish between rivers that depend significantly on aquifer discharge to sustain their dry weather flow and on which aquifer is dependent as a significant source of recharge. And the three illustrations at the bottom shows a situation where you've got streams that are gaining or receiving this discharge from the stream, and these are known as gaining streams. And then in the second illustration, we have a situation where the stream is recharging the aquifer, and this obviously is known as focused recharge. Eventually, because of changing weather, this stream may dry out, right? Especially that the flow in this situation is seemingly very dependent on precipitation that eventually finds its way into the river. It may eventually dry out, and therefore there no longer might exist a connection between the stream and the aquifer itself, as you can see in the last figure. So it's important to know what sort of relationship exists whether you've got some level of focused recharge or instead the aquifer is discharging to the stream. Now, the zone or the area around where this interaction is taking place between the aquifer or underlying groundwater zone and the surface aspects to do with the stream or river has been known to be a very interesting environment or area. And normally we refer to it as the hypoheric zone. It's very unique in terms of the conductance of that particular environment, and obviously it is meant to ensure that there is a smooth transition in terms of the exchange between the aquifer and the stream in this case, and vice versa. Right, in the last presentation in part 1, we did highlight that pumping wells have a tendency of drawing water to themselves. Okay, now in this typical situation, we expect that the groundwater will discharge to the low-lying stream, and as you can see here in terms of the movement of the groundwater, this is moving towards the stream. But the minute you introduce in some pumping through a pumping well, this obviously will divert part of the stream groundwater flow to flow towards the well, right? And depending on how much you are stressing this particular well, it might be so that now some of the water that is supposed to be heading towards the stream, all of it now begins to be released out as discharge to the pumping well. Right, it's very important also to note that our wetlands can interact with the groundwater. So they can be groundwater dependent wetlands, and this is what we want to discuss here briefly. So similar to streams and lakes, wetlands can receive groundwater inflow, recharge, or both. Okay, now, wetlands that occupy depressions in the land surface have interactions similar to lakes and rivers. Wetlands can be present on slopes, right? So besides them being present in depressions, they can also occur in slopes. The water table might intersect the land surface, causing groundwater discharge, which permits the growth of wetland plants. Okay, and obviously this is some sort of a spring area where you've got particular type of plants that are feeding off from the groundwater. Riverside wetlands receive groundwater discharge. They especially have very complex interactions, right? especially those that are sitting in low-lying areas, and then you've got this interaction. Normally, it's quite complex in terms of the feedback interactions between the groundwater and the surface water. And of course, they are subject to periodic water level changes depending on the nature in which that particular wetland is, and climate conditions and all these issues to permeability aspects as well. Right, so with increased abstraction and pumping activities, as we saw, this tends to have an effect in terms of groundwater discharge to wetlands as well. So the reduction of groundwater discharge to springs and the stream base may lead obviously to the dwindling levels in terms of the water table, and this obviously tends then to stress the wetland, and therefore causing some sort of loss in terms of resilience in these kinds of wetlands. Okay, and you can see very clearly here the water table, and of course, because the water table intersects with the topography, it forms some sort of a dambo or wetland area, and in these dambo areas, you have peculiar kinds of vegetation which are very much groundwater dependent. And the minute pumping action is introduced, it means that these areas will be stressed, and therefore this vegetation might be lost, hence affecting the ecosystem services in some sites. Okay, the case of saltwater intrusion is typically twofold, right? It can obviously happen in coastal areas. Now, coastal areas have got a natural balance between existing salt and the freshwater environment, so to speak. Now, if overpumped, the salt water, upconing occurs, which mixes with the fresh and the salt water. And obviously, this tends to be irreversible, right? And you can see a very clear, situation here where obviously because of density, right, the salt water tends to be at the bottom, tends to sink. But the minute you introduce in pumping and you go past this balance, it means that you're going to introduce in some upconing of some sort, which inevitably contributes to increase salinity from a coastal situation. Okay, obviously there are different sources of salinity, as this figure illustrates. You can also have salinity in a situation where you've got some phreatic evaporation. So evaporation that is coming out from the water table, and this is a case that we see in places like the Okavango, where you've got all this vegetation which is obstructing huge amounts of water from the water table, and because the area is endorheic or closed, therefore it means that you've got an increase in terms of salinity. There can also be sources, anthropogenic sources of salinity from things like irrigation as well, which then eventually finds its way into the groundwater. An interesting perspective also for Southern Africa is that of paleo salinity. This is salinity that is coming out from old paleo systems that have buried some salinity at depth, and because of pumping, this tends to then interact with the borehole, and then obviously bringing out this high salinity perspective. This is the case that we see in Southern Africa, between the border between Zambia, Botswana, and Zimbabwe, where you've got this old paleo lake system with high salinity areas. And basically, the area is inhabited by rural population, and obviously struggling with issues to do with salinity. And what we've seen in this area is that the salinity there is obviously a consequence of this old paleo lake system, which has now been buried, and we can't get rid of it. It's not being replenished and freshened out. So salinity in this area, based on the transmissivities that exist, is something that requires further investigation. Thank you.